Hi, folks. Today we're going to learn how to add and subtract polynomials. Perhaps you're wondering what a polynomial is, and we'll get to that in just a second. First, we're going to just look at that word. Poly means many. Nomial actually means name, but this means many names. Um, so if we're going to talk about things that have many names, let's talk about things that have just one name first. So let's look at the word monomial. Mono means one, and a monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. So right here are a whole bunch of examples of monomials. So 10 is a monomial. It's just a constant. There's no variable there, but it is a monomial. We have 3x. There is a variable there being multiplied by a constant. Here we have a couple different variables multiplied by a constant, and here we have a negative constant multiplying our variable. And the variables can have different degrees. It's a measure of the exponents on the variables. But those are examples of what monomials are. Now, a polynomial is if we take one or more monomials and add or subtract them from each other. So 10 plus 3x plus 4x squared, something like that, would be a polynomial. Degree of a monomial. This is going to be the sum of the exponents of variables in the monomial. So here, if you look at the monomial 10, there is no variable there. You can actually think of it as there being a variable there, but the variable has the exponent 0. And as we learned last chapter, when the exponent is 0, any number to the 0 power is just 1. So I'm basically just doing 10 times 1, which is, of course, 10. So because that exponent there is 0, the degree of my monomial is 0. Here I have 3 times x. X doesn't have an exponent written on it, but anything raised to the first power is just itself, and we don't typically write that exponent 1 there. So this variable in this monomial has the degree of 1. In this next example, we have 2 variables, and so we need to think about each of their exponents to determine the degree of this monomial. So we have a to the first power, because there's no exponent written there. The implication is that the exponent is 1. And the b has an exponent of 2, and 1 plus 2 is 3. So the overall degree here is 3. Here, there's only one variable, and that variable is 5, so that one's quite straightforward. The degree for this monomial is 5. Now, when we're talking about polynomials, like this one that I wrote up top, with polynomials, each monomial in the polynomial is called a term. Just it's easier to say. So this polynomial has 3 terms. That makes it a trinomial. Tri means 3, like a tricycle. So a trinomial has 3 of these terms in it. If my polynomial had 2 terms in it, it would be a binomial. And that's where those words come from. Now that we have some of our basic definitions down, let's go ahead and look at some examples. So, finding the degree of monomials, kind of talked about it in the data table up here. Let's do some on our own, and I would love for you to pause the video and try to do them before I do them. Find the degree of each monomial. Here we're going to add the exponents of the variables in the monomial. And if we have a constant that isn't 0, then the degree is going to be 0. And if you did actually have just the number 0, a constant, but it's not non-zero, then it doesn't have a degree at all. So 5x squared, here's my variable. So I look at the exponent of the variable. I only have one variable here, and so the degree is 2. In this example, I have 2 different variables here, so I have 2 different exponents to think about. I have the exponent here to think about, as well as the exponent on the y. X has an exponent of 1, Y has an exponent of 3, so my total degree here for this monomial is 4. For question C, two variables again to think about. X is cubed, Y is cubed, and 3 plus 3 is 6. And lastly, for question D, we have a constant, and constants just have a degree of 0. Let's look at some things that are not monomials and find out why they're not monomials. This here is not a monomial because it is a polynomial. You can't have an addition sign or subtraction sign inside of a monomial. This f is not a monomial because when you have a variable in the denominator, that's the same thing as writing the variable with a negative exponent. We learned about that last chapter. And when you have a negative exponent, when you have a monomial, you have to have whole number exponents. Whole number exponents. So 0 or positive integers. You cannot have a negative integer as an exponent. No negative exponents. Also, you cannot have any fraction or decimal exponents. Okay. For example G here, 4 to the a power, you cannot have a variable in the exponent. It has to be a whole number, not negative, not a fraction. And if it's a variable, then it could possibly be not a whole number. So no variables in the exponents. Lastly, I did already say this, no fraction exponents because the exponent has to be a whole number. A fraction is not a whole number. All right. Next, now that we know a little bit about monomials, we're looking at polynomials, but there's going to be a correct way to write polynomials, and it's not the way I wrote this polynomial up top. The correct order for writing polynomials is starting with the term with the largest degree and then working your way down to lower and lower degrees. So in this example, this is a second degree monomial. This is a first degree monomial, and this is a 0 degree monomial. And so the order for writing this is 4x squared plus 3x plus 10. And this order is important because that leading term, that first term, when you write things in the correct order in this standard form, is going to be important for many of the things we'll do this chapter. And so you'll want to know, for instance, like the leading coefficient here would be 4. It's the coefficient for that leading term. Also, the degree of the polynomial is based off of the degree of the greatest monomial, the monomial with the greatest degree in the whole expression, in the whole polynomial. So let's go down and write this polynomial in standard form. Well, if I look at this one, I only see one variable. This is first degree. I look at this monomial and it has an exponent of 3, so that's the third degree. And then 3, that's just 0 degree there. So the correct order for me to write this in is negative x cubed plus 15x plus 3. What's the degree of the polynomial? Well, now that I've written this in standard form, it's really easy. I just need to look at that leading term, and that term has a degree of 3. So this is the a third degree polynomial. What's the leading coefficient? Well, that's the number that multiplies the variable on the leading term, and the value there multiplying my x cubed is negative 1. Remember, if no number is actually written there, the implication is that the number is 1, but since this has a negative sign in front of it, this coefficient is negative 1. So let's look at a few examples, a few problems, and we're going to write them in standard form. determine the degree of the polynomial, and then also classify it using the correct prefix. So if there's just one term, we'll call it a polynomial. 2 terms, we'll call it binomial. 3 terms, trinomial. And 4 terms, we'll call it tetranomial. The standard form for this polynomial, well, there's only one term in this polynomial, so it's already in standard form. There are no changes to make. This is a 4th degree polynomial, and it is, in fact, a monomial because there's only one term. Looking here, this has 3 terms, so it's a trinomial, and I need to figure out the degree of each term in the polynomial so that I know what order to write it in. Here I see an exponent of 2, so that's 2nd degree. This is 1st degree, and that's 0 degree. So I will go in the order 5x squared minus x plus 4. And to get the degree of the polynomial, I need to just look at the first term. So my degree is 2. For my last polynomial, I see 2 terms. So this is a binomial. And 5th degree, 1st degree. So I want to write this in the order q to the 5th plus 8q. And therefore, my degree is 5th degree because of that 5 exponent on the leading term. How do we add and subtract polynomials? The main, most important rule for doing this is you can only combine like terms. Only combining like terms. So remember, addition is commutative. You can do it whatever order you see the parts in. So when I see 2x cubed plus something x squared plus something x plus 2x squared plus x cubed minus 1, I can zoom in here on other components that have like terms and focus on adding those things together. So let me rewrite this so that it's easier to see which terms match up. First of all, it helps to write things in standard form. This first polynomial is written in standard form, but the second one is not. I'm going to write the x cubed first, and then I'm going to write the 2x squared. And notice there's no x term in this second polynomial. I'm going to leave a gap here as though there were an x term. Basically, I'm imagining that there's 0x written here. You don't have to write that down, but we're leaving a space so that the like terms line up with each other. And then I have a minus 1 here. Notice there's no constant in the first polynomial. But we're leaving a space here like there was a constant there, a space for that kind of 0 value. And I'll just fill it in with a 0 here so that you can see why we're leaving that space. So then if I wish to add the like terms, I just focus on what's here. 2x cubed plus x cubed is 3x cubed. Negative 5x squared plus 2x squared is negative 3x squared. X plus 0x is just x, and 0 minus 1 is negative 1. So I've added my like terms together, and I have my final answer. Let me show you a different way to kind of combine like terms. I did set up question A kind of with a vertical setup. This time I'm going to do a horizontal setup, and I'll try to color code it so that we can see all the parts that go together. Here I'm adding 2 polynomials. Here I've got an x squared. So I'm going to combine those together. 3x squared plus x squared. Let's see what we get next. Let's look at our x's next. Positive x, positive 4x. X plus 4x. And now I'm going to add the next component. I've got a constant of -6 plus 10. So I've um, accommodated all of the terms in each polynomial. I've written them all down, but I just reordered it so that all of my like terms were next to each other. So what I'm going to do now, 3x squared plus x squared is 4x squared. X plus 4x is 5x. And -6 plus 10 is +4. And so now I have the final answer for this addition problem. How about subtraction? How do we handle subtraction with polynomials? When you're subtracting a polynomial, you are really adding a polynomial that's been multiplied by -1. So what we're going to do is we're going to take this negative sign and we're going to distribute it to each term inside the parentheses. So I'm going to have 4n squared plus 5 as my first polynomial. But I'm going to add, and now I'm going to do -1 times everything inside the parentheses. So -1 times -2n squared is +2n squared. -1 times 2n is -2n. And -1 times -4 is +4. Now this is an addition problem, and I can do it exactly the same way that we did in examples A and B. I'm going to group together 4n squared and 2n squared. And then I will group together. Oh, look, there's no n variable in this first polynomial, but there is here. So I'm not going to group that -2n with anything. I'm going to leave it by itself. And then I'm going to include my constants 5 plus 4. And then I will add the components together to get my final answer. I've got 6n squared minus 2n plus 9. So once again, subtraction is basically adding a polynomial that's been multiplied by -1. Make sure you did, when you distribute that -1, you change the signs on every single term inside the parentheses. Anything that's negative becomes positive. Anything that's positive becomes negative. So to finish, let's look at a real-world example. These kinds of equations where with exponents are used a lot in physics with objects that are free-falling. And so that's what's happening here. A person high up in a building is throwing a red water balloon straight down from a height of 200 feet, and somebody lower down in the building from a height of 100 feet is dropping a balloon. So the red balloon travels faster because it's been thrown, but it's higher from the ground. And we're being asked to write a polynomial that represents the distance between the water balloons after t seconds. Well, if you want to know the distance between two objects, if I'm here at the, I don't know, 100-meter mark, and my friend is here at the 75-meter mark, then the way I get the distance between our 2 points is by subtracting those distance positions. 100 minus 75, we're 25 meters apart. So we're going to do the same thing with the polynomials here. I have my -16t squared minus 40t plus 200 as my first polynomial, but I'm going to subtract away the distance where of the blue balloon, the -16t squared plus 100. I left a gap here where the 40t was because there's no t variable here in this second one. But in this example, I'm not adding, I'm subtracting. Therefore, let me actually do this in a different color. Therefore, I'm going to flip the sign on every term that's inside the parentheses. So that negative becomes a positive, and this positive becomes a negative. Um, so let's combine the like terms. 16t squared plus 16t, I'm sorry, negative 16t squared plus 16t squared is just 0t squared, but that's just 0. The whole term disappears. And negative 40t, I'm not adding or subtracting anything from that, so that stays as 40t. And then I have 200 minus 100, which is 100 as my constant. So here is my final polynomial to represent the distance between those two water balloons. So what does this mean in kind of real life? How do I interpret these numbers? Well, what this means, because I've got a constant here, that constant tells me that those balloons start 100 feet apart. Balloons start 100 feet apart. Then this negative 40 that's being multiplied by t, for every 1 second that the balloons fall, they get 40 feet closer together. Every 1 second, balloons are 40 feet closer together. So hopefully that helps you kind of see how to add and subtract polynomials. I hope this helped.